want you to mark it yourself today. Okay, so what we are going to do, we will discuss, we'll look at the 3 lab report from your neighboring class. So we'll go through it one by one, see where is the mistake, and then how to score well in a lab report. Okay, so they got a very good lab report there. And then report 4 and report 5 is from your class. So later we'll see who is the lucky winner. So we'll go through 5 lab report today. Okay, 3 I mark it already, and then 2 is the one that we're going to mark it together. And then we will go through experiment 2 together. Okay, so we'll go to experiment 2 starting from observations. So how to do observations and so on. So now let's look at the first report. Measurements and uncertainty. Now before that, what is missing in your lab report? Now you have to know in your report writing test, right, you need to write down your informations. So apparently this the first mistake in this lab report is there's no name. Okay, name is missing, and then class is missing, and then a number metric is missing. Okay, your matrix number, you need to have it, especially matrix number, because that is what we use in the exam. All right, we key in your score, we write down, you jot down your score, everything is based on your metric numbers. So metric numbers actually is more important than your own name. All right, so make sure anything that you do in matriculations, it comes with a metric number. And then, okay, now you have a title, that is good. And then objective, correct. So 2 objective. And data of experiment. Now, one of the issue in this experiment is because like this fella, he skipped everything. So there's no what? There's no theory. Theory missing. List of apparatus missing. And then procedure missing. Now, if this happens in the exam, straight away, at least 2 marks will be deducted. All right, because of all this missing part. So 2 marks will be deducted because of no theory, no apparatus, no procedure, at least. All right, so every year they have a different marking scheme. So I don't know how many marks this year, but previously, right, it's 2 marks because of incomplete lab report. And then after procedure, proceed to length. Now, the first mistake in this report is that now you record everything in 1 decimal place, which is correct. Now, how do I know that 1 decimal place is correct? Because of the sensitivity of the tool. So sensitivity tells me that your apparatus, your ruler can measure up to 0.1 cm. Okay, so this is 0.1 plus minus 0.1 cm, which is the uncertainty. And then the value record is also 1 decimal point. That is correct. But when it comes to average value, okay, average value should follow them. All right, you can measure only up to 1 decimal point. So when it comes to average, how can you have 2 decimal places? Okay, it can be more accurate, right? So you can only measure the accuracy up to 1 decimal point, but when you calculate average value, you say it's much more accurate right now. So that is not. So it should be 1 decimal point. So if this is 1 decimal point, then L minus Li, all of them should be 1 decimal point. Okay, all of them should be 1 decimal point. So this is another mistake. So when it comes to here, okay, he rounded up to become 0.1 cm. That is fine. So rewrite the answer in terms of L plus minus delta L. Now, why is it wrong? If you look at the values written here, all right, here got 2 decimal places. Here only got 1 decimal place. So it means that it is inconsistent. Your accuracy is up to 1 decimal place, but your reading is up to 2 decimal places. Your average value is up to 2 decimal places. So it doesn't make sense. So this one, again, it's wrong. And then percentage of uncertainty, okay, the way the formula is correct. So the value used here, okay, can be accepted. Why? Because it's taken from this part, okay, L plus minus delta L. So your percentage of uncertainty, the value must be coming from here. Okay, the value must be coming from here. So 0.1, you put it as a delta L, 20.64, you put it as a denominator. So calculate, you got 0.48. All right. So even though you shouldn't have 2 decimal place, but this one, because your error, you make it in the previous step. So this one usually won't be deducted. Usually. All right. I don't know about unusual situation. but usually the score won't be deducted because you have already made a mistake in the previous step. So the marks are already being deducted once. Okay, so again, here, same mistake. So the table is all right. The header got an uncertainty. Okay, so the measure, so the things that you measure with measuring apparatus, okay, with measuring apparatus, remember, it must come with uncertainty, okay, plus minus 0.1 cm. So the ones that you calculate without using the measuring apparatus, okay, you calculate based on formula, is in terms of cm only, the unit. And then everything's okay, it's correct, this one. And then again, when it comes to average value, again, it's wrong. So L minus Li is wrong because got 2 decimal places here. And then the final answer got rounded up to 0.1. All right, this is accepted. Now, how am I going to mark it in your exam? Exam, one table is worth 2 marks. Okay, one table is worth 2 marks. One mistake minus 1 marks. This one, average value, already 1 mistake. And then when it comes to L minus Li, this actually is considered as 5 mistakes. So altogether, there are 6 mistakes. So this table, 2 marks will be deducted again. Okay, 2 marks will be deducted again. And then you look at the L plus minus delta L, that is fine. This one okay, and on this one okay, sorry. Because again, it's 2 decimal point and 1 decimal place. So again, it is not accepted. All right, then percentage of uncertainty, correct formula, all right, and then a correct percentage. Diameter of a ball bearing, yes?
Nak tanya, dekat average tu kena letak unit ke?
Dekat average ada tak ada unit tak kisah. Okay, dekat table dia tak penting sangat. Yang penting, when you rewrite it in a plus minus form, then okay, this one must have unit. Right? So sebab dia, kenapa? Okay, the final answer, the L, don't need unit actually. Why? Because you already put it in the header. Kamu punya header sudah ada unit. Okay, here. So the final answer, with or without unit, it doesn't matter. Okay, now the diameter. Diameter, you measure it with a micrometer screw gauge. Okay, diameter of the ball bearing, of the oval shaped object. So this one, okay, in terms of a plus minus 0.01 mm, which is correct. So you see, you have a unit here already. That's why I told you the last step, with or without unit, it doesn't matter. So now, according to your uncertainty, you can measure up to 2 decimal places. So all values, they are being recorded in 2 decimal places and it's consistent. This is good. But when it comes to average, once again, you see it becomes 3 decimal places. This one is not acceptable. All right, and again, you see the unit now becomes cm. Just now is mm, but now becomes cm. So again, the uncertainty, the d minus di is wrong because of 3 decimal places. All right, your sensitivity can only record up to 2 decimal places. How can it become 3 decimal places when you subtract it, right? So this one, again, is not acceptable. And then the D, all right, again, this is 3 decimal places, not acceptable. So this one, D plus minus delta D, again, it is not consistent, all right? 3 decimal places, 2 decimal places with a wrong unit. So wrong unit now. Table, it worth 2 marks. D plus minus delta D, it worth another 1 mark. So if you got the wrong decimal place or you got the wrong unit, then this 1 mark will be deducted. Okay, 1 marks again will be deducted because of inconsistent decimal places or incorrect unit. Right, next. So this one, all right, get a correct answer again because just apply the equation. Now, next one. The width of the dumbbell handle. All right, dumbbell handles. Okay, dumbbell handles, you use a vernier caliper. Vernier caliper now is just plus minus 0.1 actually. Okay, dumbbell handle is plus minus 0.1 mm. So this one is incorrect. The other one, mm, is correct. So you can measure up to 1 decimal place. So this one, okay, this students, wait, let me see. Yeah, these students, he got the wrong record. Okay, I overlooked this one. So this one is wrong. Because a dumbbell, you use vernier caliper, it should be plus minus 0.1 mm only. So it is impossible for you to read up to 2 decimal places. So average value, again, is wrong, all wrong. And then again, this is wrong, okay, because it should be 0.1. So again, inconsistent. Right. So this is how we mark your final paper, okay, your exam paper. So we will check one by one. We'll look at the table, see whether you got the correct header or not, and then we will focus more on the decimal places, whether it is consistent or not, all right, whether you record it with the correct decimal places or not. And then L plus minus delta L, right, we're going to see whether you have the same amount of decimal places and calculate the percentage of uncertainty. Okay, so discussion. This is a very, very poor discussion. First of all, you should write it in terms of paragraph. And then first one, result of the experiment. What does it mean by result of the experiment? You have to refer to the objective. Objective asks you to calculate length and also uncertainty. So first paragraph, okay, these students just give me 4 readings on the length without the uncertainty. Okay, without the uncertainty. So in this case, 1 mark will be deducted. First paragraph, it worth 2 marks. So 1 mark will be deducted because of no uncertainty, right? And then another 1 marks, okay, that is fine because they got all the reading.
Adam,
Yes?
kan eksperimen ni bukan ada 6 ke?
Ya, so pelajar ini dia memang malas. Kamu tengok kan, dia punya theory pun tak tulis, dia punya apparatus pun tak tulis, dia punya
Jadi
prosedur
kalau
pun tak.
macam yang ni dia bagi 4, patutnya 6 kan?
So
So,
dia
kalau
punya
tak
markah
result.
akan ditolak di atas, dekat bahagian observation.
Oh,
So bahagian
so,
observations, kalau dia ada 6 sections punya markah, dia cuma dapat 4. Lagi 2 section dia dapat kosong markah.
oh, okay.
Okay,
So, yang ni tertolak lah kan?
yang dekat first paragraph, dia tengok yang kamu kira punya result dekat atas saja. Sebab atas sudah tolak sekali, dekat sini dia tak akan tolak lagi. So
okay.
every mistake, we will only penalize you once. Okay, we won't penalize you twice. So markah sudah ditolak atas. So sini kalau anda buat dengan format yang betul, so usually we just deduct 1 mark because of no uncertainty. And then error precautions, you see why I say this is a very lazy lab report. Only 1 error and 1 precaution, and somewhat is incorrect. All right, now it says parallax error occurs when using meter rulers. And what is parallax error? How does it happen? Explain. Okay, so don't just give me 2 words, parallax error. Then what is it? So I need to explain a little bit. And then I say no mixture in the precaution. How are you going to make sure your eyes are perpendicular to the scale of reading? Am I going to stick the ruler beside your eyes so that I know your eyes and the mark and the scale of the ruler, they are always perpendicular? I don't know, because you didn't tell me the proper step, the proper precautions. Okay, you didn't tell me what should I do to make sure the eyes are perpendicular to the scale of the reading. So no action, I don't know. So what am I going to do? Maybe I pluck out your eyes, I put it on top of the reading, maybe, or maybe I stick the ruler to beside your eyes so that the eyes and the scale of the reading, they are always perpendicular to each other. I don't know, right? Because you didn't give me any suggestions. You just say make sure. So remember, make sure is not a precaution. All right, whenever I see a terms make sure what, straight away I give 0 marks to the precaution. And some more, why do I want to ask you to explain more? Because in your final exam, the report will be marked by 2 lecturers, not just me. If I understand but the second lecturer doesn't understand, then still you're going to get 0 mark. Okay, you're still going to get 0 mark for that explanation, for that error, for that precaution. So you need to write something in general that when everyone read your lab report, he or she can understand what to do. What does it mean? All right. So don't just say, okay, now parallax error occur. When did it occur? How does it happen? So explain a little bit. Now you say make sure the eyes are perpendicular. This one, okay, I don't have to wait for the second marker. Straight away, I know nobody will accept it. Not just me. Okay, almost every lecturer, they won't accept this answer because this is not an answer. This is not a precaution. If you say make sure, then everyone know. Okay, I just need to write an error. Let's say, okay, for example, there's air resistance. Then precaution, make sure no air resistance. Done, right? So make sure it's not a precaution. You give some things where people, when they read your lab report, they know what to do to overcome the error, to reduce the impact from the error caused by the error. So make sure it's not a precaution. So apparently this is a very poor discussion. 4 marks will be deducted again. All right, so error 2 marks, precaution 2 marks. That's why I say minimum you need to give me 2 errors, 2 precaution. Maximum I can accept up to 3 each. 3 errors, 3 precautions. Then I will mark the 2 correct answer. Okay, in case there's a 1 wrong, then I will ignore that 1. I will take the 2 correct answer. All right, so you see, discussions altogether 6 marks. Now these students only got 1 mark in the discussion. All right, 3 marks, 5 marks. Okay, 5 marks was 5 marks gone because of incomplete discussion. Okay, and then conclusion. So conclusions, all right, the first part of the conclusion is correct. Objectives are achieved, and then state your result. Okay, now state your result is not a requirement in matrix, but I want you to make it a habit. Because in university, you must state your result in the conclusion. Why? In university, you need to list down all of the error, okay, as much as possible. So usually the error can be up to 10 or 20 pages. So if you discuss the result in the first paragraph, all right, in the first paragraph of a discussion, when it reaches the conclusions, people are already forgotten what is the result. That's why you need to restate it in your conclusion. Make it a habit. Restate your answer in the conclusion as a proof that objectives are achieved, as a proof that you have successfully carry out this experiment. Okay, so and also as a reminder to remind the people what was the things that you were doing. Okay, what was the experiment? So make it a habit. State the results in the conclusion. All right, now let's go to the picture. Okay, a lot of you measures the length of the book like this. Okay, apparently this is wrong. Why? Because if you place the ruler on top of the books, how are you going to know that the edge of the ruler is parallel to the edge of the book? Right? So you want to measure it, but the way you put it, you are not sure whether you are measuring the length or the diagonal of the books. So what should you do? Now, let's say this is your books. Okay, this is your books. You should place the ruler beside the books. Okay, kamu guna tulang belakang buku. So you measure that one. So you put it beside the books to measure the length. So when you put it close to books, you are actually making sure that the ruler and the books, they are parallel to each other. So you are measuring the length of the book. All right. If you put it on top of the books, basically this is what I see in almost every report. If you put it on top of the books, then you are not sure whether you are measuring the length or maybe the ruler sang it a little bit. So you are not measuring the actual length of the book. So this is an incorrect way of doing experiment. So incorrect way of doing experiment, the mark will be deducted in practical skill class. So in a lab, you will have 2 different tests. One is a practical skill test, which is the test that we see whether you know how to carry out the experiment in a correct manner. And then the report writing test is where we are going to check your lab report, see whether you know how to write lab report or not. Okay, so apparently this one mark will be deducted in the practical skill test because you use the wrong technique to measure the length of the book. Right, so again, this one is also wrong. So you shouldn't put it on top of the books. And then the last 2 shouldn't be an issue because you're just using software. But in a class, in a practical skill test, we will see how you use this, especially micrometer. Why? Because you have some things called ratchets here. All right, you have to use ratchets to control the pressure exerted on the object. So that is one of the things that we will judge in your practical skill class. And then last one is the vernier caliper. All right, so done. This is the first experiment, and apparently this is a very, very poor experiment. All right, so if this is how you write your report in the report writing test, you're going to get an F in your report writing test. All right. So let's look at the second report. So second report, now this is a very good lab report. So first of all, got name, got matrix numbers, and then got class, and also got date, which is very good, right? And then got the title, objective, both objective are correct. And then got a complete theory. All right, complete theory. So got all of the equations. Now, theory, you must show it. Why? Because all the equations that we're going to use, they put it in theory, including experiment 2. All right, experiment 2, there's an equations that we will use in our calculation, and it is in the theory. So if you don't write the theory down, then how do people know which equations to use? What are you doing, right? Which equations you use to calculate your final answer? And then this one, okay, this is very good because she got all the sensitivity. So a lot of you miss out the sensitivity. You forgot to state the sensitivity in the list of apparatus. So if no sensitivity, 1 mark will be deducted. All right, so sensitivity is a must because you're using measuring apparatus. You need to tell the reader what is the sensitivity of the tools that you're using, so that people, they can have an idea on your readings, your final answer. See how accurate it can be. All right, so if you use something that is not very sensitive, then of course your answer won't be very accurate. So if you use a very advanced tool that can read up to maybe nanometer or something like that, then your answer will be very accurate. So list of apparatus actually is very important. It gives people's first impressions on what types of experiments you're doing, and also what is the levels of accuracy of your readings of your experiment. All right, now a procedure. So procedure, this one is also very good because she knows how to change it into a present simple tense. So the appropriate instrument is chosen, okay, not was, not has been, not have been, not had been, okay, is chosen for measurements of the length of the books, diameters of the oval shaped object, and the width of the dumbbell handle. So this one, she only got a careless mistake. So in your lab report, okay, you shouldn't put all the nouns here, okay, all the this one called pronouns if I'm not mistaken. Okay, you shouldn't have all the I, you, we, they in the lab report. So I, you, we, they, them, yours, all these terms, it shouldn't exist in a scientific report. All right, so this is just one minor careless mistake. Okay, and then recorded in the following table for at least 5 reading, and table 3.1 is refers as an example. Step 2 is repeated. Okay, and then the percentage of uncertainty is determined. So that is how you write your procedure. All right, you change it to present simple tense. Okay, present simple tense. So this is how you write it. So observations first, okay, got a 0.1 cm. So uncertainty with the unit, and then got a header with a cm because this is a calculated value. All value they are being recorded in a 1 decimal place, correct? And then average value also 1 decimal place. So this one, all 5 of them, they are 0.0. So table 0.0, that is fine. Okay, because I told you, table, you got 0.0, it doesn't matter. Just that when you write down as L plus minus delta L, remember to change 0.0 to the 0.1. Because 0.1 is the sensitivity, is the smallest uncertainty that we can have based on our experiment. It is impossible to get delta L equals to 0.0. So this one, you got 0.0, just I would say coincidentally. All right, coincidentally, you got a 0.0. So it doesn't mean that there's no error in your reading. So in your reading, if you calculate by using this table and obtain delta L equals to 0.0, that is fine. But when you write it down as an answer, as a result, in the result form, L plus minus delta L, you write down as 20.8 plus minus 0.1. So where do I get this value? I got it from the header. Okay, header tells me that the measuring apparatus that I use has a sensitivity of 0.1 cm. Therefore, here I use 0.1 because this is the smallest value that we can get. We can't get any smaller than this. Right? We can't get any smaller than this. So a percentage of uncertainty, okay, so got a 0.1. Remember, don't use 0.0. 0.0 is in the table. The values that we want to use to calculate percentage of uncertainty, it should be based on, okay, the 0.1 should be coming from this. Okay, it should come from L plus minus delta L. You don't look at the table anymore. Okay, percentage of uncertainty must be calculated by using the results, L plus minus delta L. Okay. So this is a very good report. So all the calculations is correct. So we got this one plus minus 0.1 and then cm. So consistent decimal places, and then in the answer, in the results, she changed to 0.1. Okay, this is good. And then percentage of uncertainty, again, she uses a correct value. So oval shapes object, diameter, okay, 0.01 mm, D is mm, and then 4.45, consistent, okay, consistent, everything 2 decimal places. Okay, everything 2 decimal places. So you have to write 0.00. It is in order to tell the reader you have already measured up to 2 decimal place and the value is still equal to 0, right? So final answer, D plus minus delta D, 4.45 plus minus 0.01. Now you see, change to 0.01 already because of the uncertainty of the 2. Okay, uncertainty can record up to 0.01. So percentage of uncertainty again is correct. All right, so this one still the same. Everything's the same. Next one is a dumbbell. So dumbbell plus minus 0.1 mm, and then this one just mm. Now you see all the readings that are being recorded in 1 decimal place form. So correct and consistent. And W minus delta, W minus Wi, everything is equal to 0.0. That is fine. So it's consistent. So even though you obtain 0, you have to write 0.0. All right, that's why I want you to make this table so that you can see what does it mean by consistent. So consistent means that even if you got a 0, you need to make sure the amounts of decimal places, they are equal, they are the same. Okay, so when it comes to the final reading, 4.3 plus minus 0.1. So this is a very, very good report. Okay, so this one also correct. Okay, also correct. All right, now, when it comes to discussions, you don't have to write your answer in this form anymore, okay? The result obtained for the length of the book is, straight away, you can write 20 plus minus 0.1 cm. Don't need to put L plus minus delta L anymore, okay? That's why I cross it out. But it doesn't mean that the mark will be deducted, okay? This is just I just cross out the things that you don't need. But marks won't be deducted, don't worry, even if you write it down like this, okay? It's just that it is not needed. So this is a very good discussion, the first paragraph. It tells you how you should write your result. So you see the result obtained for the length of the book is 20.8 plus minus 0.1 cm with a percentage of uncertainty 0.48%. So it answered both objectives in one sentence. So this is a very good discussion, a very good first paragraph. All right, so this is how you should write it. So you just repeat 6 times because now you have 6 different objects. But don't worry, starting from second experiment, you will have maximum 2 objects, all right? Maximum 2. So it won't be too long. So this one, you just have to write down, repeat it for 6 times. Okay, now the error and precautions also not bad, just that one thing. Now, the possible error during the experiment is a parallax error. So this one, so she just need to explain it. Okay, she just need to explain it. And then this one, it must always place vertically above the mark. How? Okay, this is always my question. You tell me, you give me a lot of suggestions, but you don't tell me how to do it. What should I do? Okay, what should I do to achieve this, the precaution, the suggestions that you give in your lab report? So you need to give me the step where I can follow, okay, to achieve what you want, to achieve what you mentioned here. So here it says, she says, the eye must always be placed vertically. But how? How do I know my eyes is always vertically above the mark? That's that you want to read, right? So I don't know. So in this case, okay, 1 mark will be deducted. All right, 1 mark will be deducted. So another possible error in the experiment is 0 error. Okay, 0 error. Perhaps it would be better if you can explain a little bit. Where did it happen? Which apparatus? Which measuring tools? All right, so the precaution step is to check whether there is a 0 error. Okay, now at least she got explained. So the 0 marks coincide with each other. So if there's a 0 error, now what should you do? You subtract. Now she gave me a suggestions. If I found a 0 error, then I subtract the 0 error. So this is a good precaution. This is a good discussion. Okay, this is a good discussion. So first of all, she told me how to check for zero error. So check whether the 2 0 mark, they coincide with each other or not. If not, then what should I do? I subtract the value. See, now this paragraph, it gave me a clear instructions on what should I do to overcome zero error. Okay, and when did it happen? It happens when these 2 0 marks, they are not coincide with each other. So this is a very, very good discussions, even though it's short, but it's a good discussion. And then conclusions. So conclusions, she gotta mentions it again. Okay, but the answers, the result given is not in a complete form. All right. So now, as long as you mentions objective is achieved, okay, then it's measured, it's determined, or it's achieved, then usually you can get 1 marks for the conclusions already. Just that I want you to make it a habit, okay, to write result in your conclusion, because that is what you should do in your university. All right, so this is a grade A lab report. So in exam, okay, full marks is 15 marks. So if I go through this lab report, I will give her 14 over 15. So which is a grade A lab report, a very good report. So she can actually enter the exam now and score a almost full mark report writing test. Right. So that's it.
Madam,
Yes.
kan yang eksperimen ni,
Mm-hmm.
saya lupa letak apa tu, the percentage untuk setiap measurement.
So kamu sendiri tolak markah lah. Kan saya minta kamu tanda sendiri kan?
Dah tanyalah.
Ah.
Jadi kalau yang tu dia macam 6 tak ada, apa tu, percentage macam mana?
Kamu maksud eksperimen 2 ke atau eksperimen 1?
1.
Eksperimen 1 kalau kamu tak tulis, markah akan ditolak lah. So dia tengok, dia suruh kamu kira berapa kali. Kalau dia suruh kamu kira 3 kali, mungkin dia ada bagi 3 markah ke sana. So kalau ketiga-tiga kamu tak kira, kamu dapat 0 markah terus lah.
Okay.
Okay. So report number 3, okay, this one is a moderate report. Okay, not very good, also not very bad. So first, again, name is missing. Okay, tak ada nama. So name is missing. So where is the name? And then class also missing. Matrix number also missing. So all this information is missing. How am I going to know this report belongs to who, right? So report 1 now got a title. And then got an objective. Now objective, you can write it like this as well. Okay, you can combine 2 in one statement by using and. So to measure the length of the various object and to determine the uncertainty of length of various object. So usually if you just miss out 1, 2, I won't marks. I won't minus your mark. I won't deduct your marks. Okay, kalau minor mistake biasanya saya anggap saya tak nampak. Cuma kamu jangan buat mistake yang ketara sangat, okay? Sebab mistake yang ketara sangat itu memang tak boleh dibantu. So again, theory, incomplete theory, you see. This one I think is a she. She just wrote the first paragraph without all of the equation. So this one incomplete, again, the marks for format is gone. Okay, so sensitivity, also no sensitivity, so 2 marks will be deducted just because of the incomplete format, incomplete lab report. So make sure you write down everything in the correct manner. And you need to time yourself, you know, when you write lab report, when you do lab report, you need to make sure you can finish everything within 1 hour. Okay, because in your report writing test, you'll be given just an hour to complete it. So apparatus, no sensitivity for ruler, no sensitivity for vernier caliper, nothing for micrometer screw gauge. So again, this is wrong. Procedure, okay, you see, has been incorrect. So you should use is recorded, is chosen, and so on. Alright, so waktu saya explain, Anda actually boleh tanda lab report Anda juga. So sekali kalau tak faham, kita akan ada report lagi, okay? We have 5 reports all together. So you see this one, she didn't even change to the passive sentence. So the last one is correct, so it's determined. Now let's look at the table. All right, table, okay, got a correct header, plus minus 0.1 cm. This one is a cm, correct. So all value, they are consistent with 1 decimal place, including the average value. So this is correct. So again, this one, they are all correct. Now this one, I just say that if you have a value that is not exactly equal to 0.1, actually you should put this symbol. Okay, but if you use equal signs, actually it's fine also. Just that a more correct way should be this symbol. Okay, I don't know what it called, but it looks like an equal sign, but not a straight line. Okay, not a straight line, a wave shape. So length of the books is equals to 20.4 plus minus 0.1 cm. So now you got a 1 decimal place, 1 decimal place. So this is what we say consistent. So decimal places consistent, therefore you got a 1 marks. Percentage of uncertainty also correct. Next table, all right, got header, got a cm, and then this one consistent, and all this consistent. So the length of the book, again, consistent, 1 decimal place with a unique, so correct. Calculations correct. Diameter of oval shaped object. So oval shaped object, you use a micrometer screw gauge. So header should be plus minus 0.01 mm. So correct. Unique is mm. So everything is consistent with 2 decimal places. So here the d minus di also 2 decimal places. So when it comes to the results, 3.69, 2 decimal places, 0.01, 2 decimal places with unit. Now, unit should be placed outside bracket. Okay, unit should be placed outside bracket. And then percentage of uncertainty. So, all right, this one. So, again, this one, okay, this one, they are all correct. So, if you got the one table correct for experiment 1, usually all 6 of them should be correct. The only possible mistake is just the uncertainty. So, everything is correct. Again. So unique is outside bracket. Okay, unique is not inside bracket. Okay, now this one, why is it wrong? So your apparatus, your vernier caliper can only let you record up to 1 decimal place. Then you shouldn't write it as 0.10. 0.10 is 2 significant figures. Means that you can record up to 2 decimal places. So in this way, okay, the way she wrote it is wrong. Even though she got the correct value, 1 in 0.1, but because she added a 0 behind 1, then 1 mark will be deducted. Okay, 1 mark will be deducted because of this 0. So you see, when she records, she get everything in 1 decimal place only. So why do you want to make the uncertainty becomes 2 decimal places, right? So that's not needed. So the uncertainty should be 0.1 plus minus 0.1. So the rest, okay, the rest okay. The rest in a consistent decimal places. So again, you see this one, the weight of a dumbbell 5.0 plus minus 0.10. Why do you want to add a 0 here, right? So this 0 is not needed. So if you write as 5.0 plus minus 0.1, then you get a full marks here. Percentage of uncertainty. So percentage of uncertainty, okay, we got the correct answer. Now let's see. Okay, again, same mistake. So again, 1 mark will be deducted. The rest fine. Okay, now this one. This is a very, very, very lazy discussion. So start from first part until observation looks nice. But when it comes to discussion, this is what she gave me. So I don't even bother to read. Why? Because you are not following my instruction. What is zero error? What is parallax error? You don't even tell me what is this 2 error. What is it for? When did it happen? How did it occur? You need to explain. All right. So if you give me like this in the exam, I won't even read. Straight away, I will give you 0 mark. Okay, even though your precautions might be correct, but I will just skip it. All right, because you can follow instruction. So conclusions. So conclusion should be this one should be all right. So got the mentions, can measure the length and also the uncertainty, and then got state the result. So the conclusion is fine. So this report, the marks will be deducted in the discussion part. All 6 marks are gone straight away. I don't even have to read. Okay, by just looking at the discussion, straight 6 marks will be deducted. So that marks the end. So again, you see the same mistake. She put the ruler on top of the books. Okay, so this one also. So you should put it here beside the book. Okay, you push the ruler until it's close to the book, then you start to measure the length. So the way she measured it is incorrect. So improper way of handling apparatus, okay, in recording the data. So the rest don't have to check it anymore. So it's fine. So let's see who is the lucky winner from this class. Yes, siapa kamu?
Baik.
Oh, kamu happy. Saya tengok saja mereka dah tolak dah. Hahaha.
Taklah, cikgu berpetik rambut.
Okay, so kamu punya report, kamu beritahu saya macam mana saya nak tanda. So first, nama hilang, name. Okay, no name, no class, and then no matrix number. So in a report writing test, this will become a ghost paper. Okay, ghost paper. So title correct. Now, can you tell me the objective is correct or not? Objective betul tak?
No,
No, why not? Why not? Kenapa salah? Where is the mistake?
because depan kena ada to
Yang mana satu kena ada to.
measure dua-dua objektif.
Okay, so two measures and two determine. And then you don't need this one. This is your learning outcome. What does it mean by learning outcome? Learning outcome is the things that you can learn at the end of the class. But now the things that you write is the lab report. You are not writing class report. Okay, if you write class report, then yes, you should say at the end of the lesson. So you should learn what to do. Okay, you should learn to measure the length, to determine the uncertainty. But now you are not writing a class report. You are writing an experiment report, a lab report. So you report what happens in the experiment. Everything is based on the experiment. Therefore, you don't say at the end of the lesson. So it starts from two. So apparently this is wrong. Because what you are writing here is not objective. You are writing down the learning outcome. Okay, so this is wrong. 1 mark will be deducted because of incorrect objective. And then apparatus. Okay, so who can tell me whether the apparatus is correct or not? The list of apparatus. Betul salah? Oh, habis. Semua segan. Kalau segan, saya kena pilih orang.
No, no madam.
Oh, kenapa no lagi?
Sebab tak ada uncertainty.
Okay, good. Okay, because no sensitivity. So you got a ruler, measuring apparatus. You got vernier caliper. You got micrometer, screw gauge. So where is your sensitivity? Okay, di dalam apparatus, we don't call it uncertainty. We call it sensitivity. Okay, we look at the smaller scale of the apparatus. So uncertainty is slightly different. Okay, uncertainty, it depends on whether you are taking 1-point reading or 2-point reading. Okay, if you forgot what is 1-point reading or 2-point reading, you can go to the Google Classroom and read the notes, okay, read the handout. I did post a handout there to tell you guys what is the difference between single-point reading, 2-point reading. So sensitivity and uncertainty, there is a slight difference between these two terms. Sensitivity, based on the smaller scale of the two. Uncertainty is you already record something, but that is not accurate value, you know. Okay, due to limitations as a human, due to the limitations of the tools. So you are uncertain. So you give the reader a range. So that's that one we call uncertainty. All right, so let's see procedure. So procedure, the appropriate instruments of the length of a basic shape and a dumbbell has been chosen. So again, you see this one is wrong. So it should be is chosen. Okay, it's chosen. So the way you change it to a passive simple, to the present simple tense is wrong. For task 1 to task 3, okay, the measurement is performed or are performed. Depends on how many measurements you are recording. So the data is recorded. So it's performed, is recorded in the flowing table for at least 5 reading. Right. So table, all right. So again, have been. So same mistake. So basically, okay, you just have to correct all this thing. Okay, you just have to correct this. So have been, have be. Salah ini. Okay, have been. No, bukan. So nanti betulkan. Experiment 2. Okay, you make sure you correct all those things. Okay, now let's start from a table. So let's see. Yeah. Okay, now I'm going to choose a lucky winner. See who can tell me whether it's correct or not. Okay, Farah. Table dia ada salah tak? Is there any mistake in the table?
Yes.
Where is the mistake?
Dekat the 0.04.
Dekat 0.04 sini.
Yeah.
Okay, so sini semua salah. Apa lagi mistake dia?
And then the average value,
So what is the mistake?
2 decimal point.
Okay, so how many decimal points should she use?
1 decimal point only.
Very good. Okay, so should be 1 decimal point. And then anything else?
The average value for the
Delta
second
L.
one.
Okay, so again, this is wrong. Okay, it should be 1 decimal point. So thank you. So basically, this table, 2 marks will be deducted. All right, so 0 mark because one table only worth 2 marks, so 2 marks being deducted already. So these are the mistake. Then again here, because you got the wrong average value already, you got the wrong delta L already, so you got it wrong. Okay, so the result, usually this result will be given a range in your final exam. So if your result is within the range, then you will get marks. If it is outside the range, then you won't get the marks. So percentage, okay, percentage you calculate with the correct formula, so this is acceptable. Okay, so tengok lagi, table kedua, same mistake, all right? So header is fine, you got a correct header, but then this one is wrong, this one is wrong, this one is wrong. Okay, so the answer here, the result here is also wrong. So result must be correct, okay? Result must correct. And then a percentage of uncertainty, that is fine. Okay, let's look at the next table. Change to a red color. I think red color is better. Okay, let me choose a second winner. Okay, Howard, can you tell me whether the table is correct or not?
Yes, correct.
All right, good. So everything is correct. So D come with a plus minus 0.01 mm. So measuring oval. Oval means you're using micrometer screw gauge. So D minus DI in terms of mm, because just a calculated value. So everything, all 5 values are being recorded in 2 decimal places, and average value also 2 decimal places. So this one, everything 2 decimal places, 2 decimal places. All right, good. You know to change it to 0.01. Very good. So 1.26 plus minus 0.01. And in your percentage of uncertainty, you use 0.01 as nominator and 1.26 as denominator. So good. All right, so this calculation is perfect. So next one. Okay, next one, let's see. So the first one, D plus minus 0.01. Okay, correct. Correct. Or 2 decimal places, 2 decimal places, correct. So again, this one is a good calculation. Okay, got unique. So calculate 0.01 and then 3.32. All right, so this one, I'm going to choose another lucky winner. Okay, Mai Sarah.
Yeah.
Jadual ini betul tak? Is it correct, this table? Or is there any mistake?
Correct.
So 100% sure. From 0 to 100%, 100% sure.
Yes.
Tiba-tiba jadi tak confident. Okay, so you have the width of the handles, or you measure the width of the handles of the dumbbell. So you use a vernier caliper. Vernier caliper come with plus minus 0.1 mm uncertainty, so this is correct. So average W minus WI mm, correct. So since you have an uncertainty 0.1, 1 decimal place, so the reading recorded should be in 1 decimal places, sorry. So 1 decimal place, 1 decimal place, 1 decimal place. So when you write down, it's at a when you write down the values in the result form, 4.1 plus minus 0.1 mm. Good. So 0.1 divided by 4.1. Okay, you got it. So same table. So plus minus 0.1 mm. This is mm. All right. Okay. So 7.3 plus minus 0.1 mm. So again, calculate everything's correctly. So discussions, all right. So discussion, because you got a lot of result. So first paragraph, I let you write it in this form, but the correct way should be the one that I show you just now. Okay, so this one, all right, can be accepted because got a lot of reading. So you see, you just give me precaution. So where is the error? So apparently no error, 2 marks will be deducted. So a precaution step, identify the zero error value. How to identify? And then minus the original value by the zero minus the origin by the, okay. So avoid parallax error by placing your eye level perpendicular to the meter ruler when taking, but how? Placing eyes level perpendicular to the meter ruler. How? So again, how? Both precautions, you didn't tell me how to do it. Okay, you didn't tell me how to do it. First one, okay lah, I can accept it, but the second one cannot. So at least 1 mark will be deducted again. So just the discussion itself, 3 marks gone. All right, 3 marks gone. Conclusions, the length of various objects has been measured. Okay, the uncertainty is determined. Okay, can be, it should be can be measured. All right, because you want to know whether you can do it or not. So can. Okay, can be determined. Or is determined, boleh juga. Fine, okay, tak ada masalah. You just want to tell the readers that you managed to conduct the experiment. So state the result. Okay, state the results. All right. So this one, picture. I want to see how you measure the length of the books. Ada. Okay, this is the correct method. Okay, so you put it by the side. So you use the books to stop the ruler from moving, and at the same time, you make sure they are parallel to each other. So in this way, you can get an accurate reading. Okay, so this is the correct method. Okay, this is good. All right, done. Let's see who is the last lucky winner. Tak keluar. Wait. Yeah, it hangs. Okay. So this is the next lucky winner. Okay, so let us go through it together. So the title is all right. Okay, so got the name, got the matrix number, got class. So title is correct. Objective, to measure the length of the various objects, and 2 determines the uncertainty. So good. So let's see the theory. So theory, as long as you got write it down, then it's all right. Okay, then it's okay. You don't have to rephrase it. Okay, you can just rewrite it. Apparatus, so 2 books, 2 oval shaped objects, and then 2 dumbbells, a 30 cm meter ruler with a range. Very good. So she got both the range and the sensitivity, and then the range and the sensitivity. Very good. Again, very good. So this is a very good list of apparatus. So when I read it, I know what is the apparatus that he or she used. Okay, so procedure. The appropriate instrument is chosen for the measurements of, okay, correct. And then for task 1 to task 3, the measurements are performed and the data is recorded. All right, so okay. And then step 2 is repeated for another object with a different size. Good. And then the percentage of uncertainty is determined. Good. Okay, so this one, I want you guys to check it for me. Let's see Who is the lucky winner? Next winner. Irfan? Jadual betul tak?
I think it's correct.
You think it's correct? Okay. So it is correct. So first you look at the header. Header tells you it's the uncertainty is plus minus 0.1 and then it comes with a unit. So this is correct. Average L minus Li is in terms of cm. So it is correct. All 5 values, they are being recorded in a 1 decimal place. And then the average value rounded up to 1 decimal place. And the L minus Li, all of them, 1 decimal place, consistent. And then the final answer also 1 decimal place. But when you write it in the result form, 26.0 plus minus 0.1, good. Okay, come with a unit. So this is a very good calculations. Okay, kemas dan lengkap. Second table should be the same. So you got a plus minus 0.1 cm. And then the cm here, all 5 consistent. Final reading average also consistent. Okay, here all 5 of them, they're consistent. Final answer consistent. When you rewrite it in the plus minus form, 21.5 plus minus 0.1 cm, consistent. So percentage of uncertainty, correct. Okay, so let's see. So this is the oval shaped objects. Let's see who is next. Afrina? Nor Afrina? Ada? Atau tiada? Habis tiada. Ada.
Ada, madam.
Oh, ada. Bagus. Okay, so betul atau salah jadual ini?
Betul.
Betul. Yakin?
Yes.
Alright. So oval shaped objects, you use a micrometer screw gauge. Therefore, the uncertainty is plus minus 0.01 mm. So again, here just a calculated value. So what you need is just mm. All 5 of them, 2 decimal places, 2 decimal places, 2 decimal places, 2 decimal places. So when you write it in the results, okay, you know to change it in 0.01. So this is good. So percentage of uncertainty is correct. So diameters of oval shaped objects again. So correct, 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 correct. All right, very good. Okay, next one. Table 5. So the width of a dumbbell handle. So dumbbell handle. Next, I want to ask Shahira. Shahira, what is the apparatus that you use to measure the dumbbell handle and whether this table is correct or not?
Vernier caliper.
Okay, vernier caliper. So is the table correct?
Yes.
All right, good. So vernier caliper come with uncertainty plus minus 0.1 mm. All right, the unit for calculated value, of course, is in terms of mm. So consistent, 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 consistent. And then the readings, the width of a dumbbell handle, 5.7 plus minus 0.1 mm, good. So you got a calculated value. And then we have a next one. So correct, 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 consistent, consistent, again, all correct. So up until this point, you are still getting a full marks. All right, so setakat ini masih markah penuh. So next, let us see. Okay, so this is incorrect way of measuring it. So you should put a ruler here. Okay, you should put it here. So this one, the 1 mark will be deducted in the practical skill test. So this is incorrect. All right. All right. Okay, discussions. So the length of the book obtained in this experiment is 26.0 plus minus 0.1 cm with a percentage of uncertainty. Okay, so let's see for task 2, and then for task 3, you got handle 1, and then handle 2, the result is accepted as percentage of uncertainty are small. Okay, good. All right, so this is how you should write your first paragraph. So another excellent first paragraph. Right. So now let's see what happens in the second paragraph. So one of the error that can be found in the experiment is parallax error. So parallax error is an error in a reading and instrument due to the eyes of the observer is not in the line that is perpendicular to the planes of the scale. Good. This is what you should do. You mention parallax error and then you explain it. All right. So to overcome the error, the eye has to be placed directly above the marking or the scales of the instruments to ensure that the line is proper. Okay, now this one again, how? How do you ensure that the line of the vision is perpendicular to the scales of the measuring instrument? So if you want to give a suggestions, you give some things that people can know whether they manage to do it or not, right? Because if you just say ensure, everyone they conduct the same experiment again, they will just rewrite ensure because they don't know whether they manage to achieve it or not. So you try to give something that people do it and people know they are successful in doing it. All right. So this is not a good precaution. So 1 mark will be deducted. And then another error is zero error, which arises when measuring the instruments does not start from exactly 0. So at least you see, got explanation. So to overcome zero error, the zero has been subtracted from the reading obtained. Good. Okay. So random error may also occur, which arise from unknown and unpredictable variations in the conditions, causing the measurements to fluctuate. So all right, can be accepted. So to overcome random error and improve the accuracy of the reading, the experiment have to repeat it several times. Good. So now you see here, you got 3 errors and 3 precautions, right? So in this second paragraph, 1 precaution is not accepted, but you got the other 2 correct. So I will give you full marks in the discussion. So this one, I will just ignore it. Okay, this one, I will just ignore it because at least you got 2 correct. So if you got 2 correct, then I will give you full marks already. I will ignore the wrong one. Unless you got 2 wrong, 1 correct, then of course I have to minus the marks for one of the error. Okay, one of the mistake. So in this case, 3 error, 3 precautions. So with a very good first paragraph, you got 6/6 in the discussion. Right, so far this is the first report that I marked and that got us full marks in the discussion. Very good. So the objective is achieved. Okay, and then you got all this thing and the uncertainty. Wait, the diameter and its uncertainty. Uncertainty should be in the percentage form. Right, should be in the percentage form. Wait, questions ask you to measure uncertainty or percentage of uncertainty. It determines uncertainty only. Okay, then that is correct. Right, that is correct. Okay. So this is a grade A report where you can get 15/15 marks. Okay, full marks report. So this is what you should do. Okay, this is a very, very good lab report. So you guys can refer to this one. Okay, this one, because I recorded in the video, so you can refer to this one again in a YouTube after this. See how to write a good lab report. Okay, how to write a good discussion. So usually students will lose mark in the discussion because you don't know how to write a correct error and a correct precaution. So this is how you should do it. Give some explanation and then give some things that people can actually do it to overcome the error. Okay, so for example, to overcome zero error, you subtract the zero error that you record from the experiment. And then to overcome random error, so you take the reading several times. You take the average value. So you give some suggestions where people can actually follow and carry it out. Okay. So I think that's it. We are done with all 5 lab reports. So now I give you 5 minutes to mark your own lab report. If you have any questions, you may ask. So if you are done, then you can take a short break. We will continue again at 3:10. Okay, we'll continue with experiment 2. So this is just a sample data, don't copy. Okay, sample data, do not copy. Okay, so now I give you some time to mark your own lab report, and then if you're done, then you can have a short break. Let's come back at 3:10. Okay, so far, do you guys have any questions? Ada sebarang pertanyaan, persoalan? Okay, because we are a bit running out of time, so I don't want you to, I don't want your data anymore. I will steal the data from next class. Okay, saya curi data dari kelas sebelah. Put it here. All right. So this is how you should write a table. Okay, so are you guys ready? Ada siapa-siapa lagi yang masih belum ready? So make sure you have your data with you, you have your table with you, and then you have the graph paper with you, because we are going to sketch the graph together. All right, I want to make sure you know how to do your first graph. So a table. So table, first things, numbers of reading. Now, number of reading is not a must. Okay, it's not a must. You can start from the falling distance. So falling distance, the first thing, okay, now you check your own table. First things that you must have is the uncertainty, because you measure it with the ruler. Okay, plus minus 0.1 cm. So make sure all of the reading come with 1 decimal place. All right, so yesterday class, I caught a few of them. They just give me 45, 55, 65, 75, 85, 95. So make sure you record it with 1 decimal place because of your measuring apparatus. If your measuring apparatus can record up to 2 decimal places, then the readings record here should be 2 decimal places. All right, should be 2 decimal places. And then falling times, if you use pFox, then the uncertainty is plus minus 0.001. Okay, because it is a digital tools, then you just use the smallest value. So the smallest value that can be recorded is 0.001 second. If you use your handphones, okay, because I told you guys you can record it manually. If you have any issue with the apps, then the uncertainty will follows the phone. Okay, see, your phone can record up to how many decimal places? If you can record up to 4 decimal places, then you write plus minus 0.0001. All right, because some phone, I think you can record up to 6 decimal point. Then you have to write down all 6 of them. And then a T1, T2, T3, and then you calculate the average value. And then T square must come with S square as the unit. Okay, it must have a S square. So if you give just S, then it's wrong. Okay, 1 mark will be deducted if you just write S. So this is a good table, a full marks table. Okay, a full marks table where she got the uncertainty correct. So this is what we are going to check. The first thing, we check the header. See whether the values that you measure, all of them, they come with a correct uncertainty and correct unit or not. And then T square, S square, so correct. And then we want to check, the next thing that we check is the values that we record. So H, everything should be in 1 decimal place. T1, T2, T3, and average, all of them must be 3 decimal places. So correct. And then the next thing, T square, okay, also 3 decimal places. Okay, now to be more precise, it should be 3 significant figures. Okay, 3 significant figures. Calculated value, usually we keep 3 significant figures. Okay, calculated value, usually we keep 3 significant figures. All right, now, how to tell whether our reading is correct or not? Then you have to refer to the theory of experiment 2. Okay, theory in experiment 2, it tells you need to use the equation. You are going to plot a graph of H against T square. It's too close. Okay, H against T square. This is the graph that you're going to plot. All right. So if you refer to the theory, if you look at the theory, let's go back to the virtual lab. Go back to the theory. So you look at the theory, okay, from the starting until the end of theory, which equations come with H and T square? So we have the first equation. Now, first equation, there's no H, but got T square, so we don't want it. The second equations in our theory are, now I got the equations with H and T square. Therefore, this is the equations that I'm going to use in my calculation. So that is the technique to select which equations to be used in our calculations. You look at all of the equations in theory, and then you see which equations contain both h and t squared. So apparently the ones that we want to use is h equals to 1 over 2 gt squared. All right. And if you look at these equations, the relationship between h and t squared is that h is directly proportional to t squared. So which means when h increase, your t should increase. All right. When h increase, your t should increase. So is it correct? Let us go back to the table again. So my h start from 45 and it increased towards 95. If you look at the time from 45 cm is 0.284 second, it slowly increased until 0.421. So both increase at the same time, which means my data makes sense. Okay, just makes sense. It doesn't mean that it is definitely correct. Correct or not is based on our calculation. It's based on our percentage of error. All right, but when it comes to data, comes to the table, we want to know whether our data, the data that we measure, make sense or not. This is how we check. You look at the relationship between these two variables. Okay, you look at the graph that the questions ask you to plot, and then you look at the relationship between these two variables. Okay, and then you go back to the table, see whether it obeys the relationship or not, whether they are directly proportional to each other. All right, now, what should we do once we have this table? Again, the question tell us to, the experiment tell us to plot the graph of h against t squared. First things that you need to do after table is to calculate a point called centroid. Okay, you want to calculate a point called centroid. So how to calculate centroid? So we have x as our, if h against t squared. So t squared is our x-axis, and then h is our y-axis. Okay, h is our y-axis, x is t squared is our x-axis. So we want to calculate the average value. Okay, the average value for t squared and the average value for h. So x-axis, okay, for x-axis, so you calculate average t squared. So average t squared, according to this data, I have a 0.080 plus 0.102 plus until 0.182. Now this is according to my table. You do for your own table. So divided by 6. Okay, divided by 6 because I have 6 data. And then y-axis. Okay, I calculate the average h, which is equals to 45.0 plus 55.0 plus until 95.0 divided by 6. So from here, you will get 2 coordinates. Remember, you must write down their unit. Okay, you must write down their unit. Unit is a must. And then after that, what should you do? You write them in coordinate form. Okay, so this is your t square average. This is your h average. So you write it in a coordinate form. So you need to plot this point in your table, in your graph. Okay, you need to plot this point in your graph. Now, sometimes students, they don't like to do the calculations. If you don't do the calculations, 1 mark will be deducted. Okay, because centroid, there's 1 mark. This 1 mark is given to calculations, okay, plus plot. If you calculate, you show the calculations, okay, and then you plot it, then you get 1 mark. If no calculations, but you plot it, 0 mark. If you got calculations, but you forgot to plot it, again, 0 mark. So you must have both. Okay, you must show the calculations and then plot it in the graph paper in order to get this 1 mark. All right. So first thing you should do, centroid. So I give you 1 minute to complete your centroid before we proceed to graph. Yes. Okay, 1 minit bagi anda kira centroid anda. Kalau anda siap, baru kita tengok graph.
Madam, yang kat dalam bentuk koordinat tu perlu letak unit ke?
Koordinat itu tak payah letak unit tak apa. Okay, tapi dalam pengiraan anda wajib ada unit. Yang ini kena ada, yang ini kena ada. Okay, so now that you have your centroid, then we can start to plot the graph now. Okay, so you don't start yet, yeah? You let me explain first. So in order to plot the graph, okay, of course you must start with the title. Okay. I'm going to use blue color. Okay. So you start from a title. Okay, you start from title. So title is H against T square. So the title of the graph. After you have the title of the graph, what do you need? You need a 2-axis. Okay, you need a y-axis and also x-axis. So a y-axis is H. And remember to put unit. H bracket cm. T square bracket s square. So if you got titles and you got a label for the axis, straight away you got a 1 marks. Okay, 1 mark for this one, and then 1 mark for the label of the axis. And then the next mark will be given to the scale. Okay, so a suitable scale to use in our graph. Okay, now it's a 45, 55, 65, 0.08, 0.10. Okay, let's see. So I'm going to use 0, 0.02, 0.04 until 0.20. Here I'm going to start from 10, 20, up until 100. Okay, now a lot of students, they told me, okay, their graph, they concentrate at they all of point, they accumulate at a point 0.8. Okay, they all gather in between 0.8 until 0.20. So in that case, if you don't want to start from 0, what can you do? So you can start from a non-zero value, but you have to be extra careful with how you do it. Okay, so let's say if I don't want to start from 0, okay, I don't want to start from 0. So what should I do? So this is H in terms of cm, and then this is T s square, T square s square. All right, now if I don't want to start from 0, then I look at my first table. First table, from 10 to 0.02, this is 1 box. Okay, so if you want to start from 0.02, then y-axis must start from 10. If you want to start from 0.04, then you need to start from 20 for the y-axis. All right, so if you move here by 1 box, the vertical, the y-axis, you also need to move that up 1 box. If you move here 2 boxes, you move up 2 boxes along the vertical component. If you want to start from 0.06, which means 3 boxes, so vertical line also 3 boxes, means you have to start from 30. All right, so that is if your graph cannot start from 0. So let's say you want to start from 0.06, then here it should start from 30. Okay, 0.06, 30. So that is how you do it. Okay, so jangan guna gergaji. Okay, don't use the zigzag, because if you use the zigzag, you are going to get the wrong answer. Right. So I will stick to my first graph. Okay, I'll stick to my first graph because I have a complete label here. So the black color graph is just another option for you in case your graph cannot start from 0. So once you have all this scale, okay, we call suitable scale. So how do we know whether it's suitable or not? It means the interval. Okay, first the interval must be equal. All right, the interval must be equal for the x-axis and also for the y-axis. The interval, they are equals, and then you use a suitable scale, which is well, usually we refers to even numbers or the factors of 5. All right, we don't use a scale, for example, we don't use 3, 6, 9. Okay, we don't use 7, 14, 21. All those we call not suitable scale. Okay, not suitable scale, because if you divide, you use 10 boxes, divide by the numbers, then sometimes you can get a lot of decimal places. So in that case, we say it's not suitable. Okay, for example, if you use 7, so 10 boxes divided by 7, you're going to get an infinity decimal places. So in that case, we say it is not suitable scale. All right. So so if you got a suitable scale, then you got another 1 mark. Okay, if the scale is correctly labeled, and it is a suitable, then 1 marks. So before you plot the graph, you see you already got 3 marks already, just from the kerangka, okay, from the shape, from the label. Okay, now that I have all of a point, what should I do next? First thing that I should do is to label the centroid. So you refers to your coordinates, the coordinates that you obtain, then you label the centroid. Now, how should we plot the centroid? A cross with a circle. This circle, it tells us this point is centroid. All right. Whereas all the other 6 data point, okay, you just plot the cross. Okay, you just plot the cross. So you just plot it. Okay, you just plot it. All right. I want to change the plot a little bit. Okay, so you can start to plot. So if all point plotted correctly, then you can get another 2 marks. Okay, plotting worth 2 marks. So kalau 6 data point semua betul, then you got these 2 marks. Okay, so now I give you 5 minutes to plot. Alright, 5 minutes untuk kamu plot semua titik. Atau saya bagi kamu sampai masa 35 minit. Okay, so 35 past 3, we will continue with the next calculation. So bagi kamu 8 minit plot.
Madam,
Yes?
for the y-axis h, we should put decimal place or not? 1 decimal place.
No. Okay, you don't need to put decimal place. So okay so far? Okay, so next thing, after you have all the points plotted correctly at its correct position, one last mark is given to the best fit line. Now, best fit line doesn't mean that it must pass through the centroid. It must pass through the origin. Okay, so even though according to theory, now when you compare h equals to 1 over 2 gt square with y equals to mx plus c, it tells us that the graph theoretically it should start from 0. But now this is an experiment. So experiment, we don't bother whether your graph start from 0 or not. What we check is, okay, first thing that we check for the best fit line is whether your graph passes through centroid or not. The best fit line must pass through centroid. Okay, must pass through centroid. That's why centroid plays a very, very important role in your graph. Without centroid, then there's no best fit line in your graph. If you forgot to plot centroid, straight away 2 marks gone. Okay, the marks for centroid and the mark for best fit line gone. So centroid is very important. So best fit line must pass through centroid. And the second rule is that the graph must be balanced. Now, what does it mean by balance? If you look at my graph, my best fit line passes through 2 points. Okay, point. Let's call it 1, 2, 3, 4, 5, and 6. So my best fit line passes through 2 points, through point number 3 and point number 6. Remaining 4 points, okay, they distribute evenly above and below the best fit line. Point 1 and point 5, 2 points above best fit line. Point 2 and point 4, 2 points below best fit line. So this is what we call balance. Okay, points above and points below, they are balanced. Right? So now, okay, you try to plot this best fit line. And best fit line, plot with a long ruler. All right? Why? Because when you plot with a short ruler, sometimes it is not a straight line. When you combine the line, sometimes it off a little bit. It's sagging a little bit. Okay, when you join these 2 straight lines together. So if that happen, okay, for example, like this one, I showed on the right hand side. So if this happen, then 1 mark will be deducted. No marks for the best fit line. Okay, because it's no longer a straight line. So they are overlapping. That obviously it is a joint line, and then they are no longer lying on the same straight line. All right. So best fit line always sketch with a long ruler. Okay, sekaligus bagi dia habis. And don't stop at point number 6. Okay, let it comes out a little bit. So a lot of students, they like to stop right at number 6, but sometimes they didn't notice they haven't touched number 6 yet, point 6. So it means your line is not long enough. Okay, so the line, the graph, they are not balanced and so on. Okay. So now you draw your best fit line. All right, try until you get a nice looking best fit line before we proceed to calculation.
Madam,
Yes?
kalau plot tu, 2 dekat atas, 1 kat bawah, kira tak balance.
2 kat atas, 1 kat bawah saya masih terima. Okay, sebab kadang-kadang memang anda boleh melalui 3 point dan 3 point lagi kamu bahagilah 3-2 ke, jangan bagi 3-0.
Okay.
Okay, so once you have best fit line, what should you do next? Next, we are going to proceed to the calculations of gradient. But before that, you are going to need a triangle. Okay. Oh yeah, one more thing that I forgot to mention just now. Now, another 1 marks will be given to the size of the graph. So how do we determine the size of the graph? If the size is greater than 50% of the graph paper, then you get another 1 mark. Okay, you get another 1 mark. So what does it mean by 50% of the graph paper? We are going to look at the distance between first plot and the last plot. Okay, so this is how we use to determine the size of the graph. So if all of the plot, they are accumulated at the final part, okay, then you need to enlarge the graph. So we are not looking at the straight line, okay, not looking at the straight line. We are looking at the distance between first plot and the last plot. If the distance between first plot and last plot is greater than 50% of the graph paper, then you get this 1 mark, right? Okay, so next, okay, before we calculate the gradient, we need a triangle. And the triangle also must be big enough. All right, so we draw a triangle with a condition. The straight line must be greater than xcm, and the horizontal line it's also greater than xcm. That is the first condition. Second condition, the line, the triangle shouldn't touch any data point or axis. Okay, tak boleh sentuh data anda, plot anda, tak boleh sentuh paksi. Why? Because we want to see whether you know how to take the reading from your graph or not, from your graph paper. Okay, that is how we check whether you know how to read the data from graph paper or not. Okay, by looking at your gradient. If you draw the triangles on the plot, then you don't even need to read it. You can straight away take it from table, right? So there's one rule says that the triangle shouldn't touch any of the plot, and it shouldn't touch axis. Okay, so no, don't touch axis, don't touch plot. And if it is greater than xcm by xcm, then you can get another 1 mark. Okay, you can get another 1 mark. So the graph itself, okay, if we calculate it, actually it's quite a lot of mark. Okay, 1, 2, 3, 4, 5, 6, 7. 7 marks altogether for just one graph. Right? 7 marks altogether for just one graph. And of course, a centroid, but centroid must come with calculations. Okay, let's see. Next thing, what am I going to do next? So you guys draw the triangle first, and then get the coordinate. Okay, get these two coordinate first. I want to draw something. Okay, kamu catat coordinate dulu, saya nak lukis sesuatu benda. Three, 4, 5, 6, 7, 8, 9. One, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. So, okay, now pay attention. Okay, this is very important. So we know that gradient m is equals to y2 minus y1 divided by x2 minus x1, right? So how are we going to substitute the values taken from the graph? How are we going to read the graph? Okay, how are we going to take the data out from the graph to substitute it into the gradient? So it is very important to know how many decimal places to use. So how are we going to determine, okay, whether we want to use 1 decimal place, 2 decimal places, 3 decimal places in our substitutions? So you look at this box, okay, the first small box in your graph paper. So we take this small box, I enlarge it. So this is actually just a one box. Okay, satu kotak dalam graph paper Anda. So every boxes, you got a 10 small box by 10 small box. So what are we going to do now? We just want to look at this one very small box. Okay, we just want to look at what happens to this one small box, the value for this one small box. So for this one small box along x-axis, so if 10 boxes equals to 0.02, then at this point, we have 0.002. So for y-axis, 10 boxes represent 10. So this one small box represent 1. So the smallest box for x-axis represents 0.002. The smallest box for y-axis represent 1. But the values that we can read from the graph paper is actually half of the smallest box, which means for x-axis, we can actually read up to half of the smallest value, okay, which is half of 0.02, okay, it is equal to 0.001. So we show us that we can actually read up to 3 decimal places along x component. Therefore, any values that you want to substitute into a gradient, the equations of a gradient for x component, it must have 3 decimal places. Then how about y component? Okay, so for y-axis, smallest box is 1. Half of the smallest box, it is equal to 0.5. So which means the smallest readings that we can get is 1 decimal place. Okay, we can read up to 1 decimal place. Therefore, when you substitute the value into the gradient, the equations, all y, okay, y1 and y2, they must have 1 decimal place. All right, even if you take the 0, the value 0, then you need to write it down as 0.0. Okay, you take a round value, a round number, for example, you take 2. Okay, you record 2, then you need to record it as 2.0. Okay, 2.0. So now let's try it. Okay, let's try it. For example, now I have 1 point located at here, and my point number 2 located at here. So this is my point 1, this is my point 2. Right, I'm going to try to apply the equations. So y equals to, okay, let's see. M equals to y2 minus y1. So my y2 is now number 9. Okay, my y2 is now 9. So 9.0. Because half of the smallest value give us the values of a 1 decimal point. Therefore, you need to record your y1 and y2 as a 1 decimal point. So minus my y1 is now 2. So minus 2.0. Okay, 2.0 divided by, now let's look at x. x2. x2 is okay, 0.02, 4, 6, 8, 10, and then 2, 4, 6. So 0.016. Okay, 0.016. 3 decimal places. Okay, 3 decimal places. Minus 0.004. All right. So as you can see here now, my x, they all come with 2 decimal places, 1 decimal place, 1 decimal place, and my x value, they all come with 3 decimal places. Why? That is because of this. So this is very important. Okay, this is very important. So if you substitute all 4 value with correct decimal place, 1 mark. If you write down the equations, 1 mark. Final answer with correct unit. So now you use y divided by x. So it's a cm as -2. But now I want you to change cm as -2 into meter as -2. All right, because in your practical test, sometimes they want everything in SI unit. So you change it into meter per second square. So correct answer with unit, another 1 marks. 3 marks for calculations of a gradient. Okay, if you want to calculate the triangles together, then 4 marks for the gradient. All right, so now you try to calculate the gradient. Make sure you use the correct numbers of a decimal place. All right, correct numbers of decimal place. So bagi anda 5 minit kira, then we are going to proceed to the last part of the calculation. So we are almost done. Okay, we are almost done.
Madam,
Yes.
calculation ni better tulis atas kertas graf tu sekali ke ataupun another paper?
Another paper. Okay, graph paper cuma ada graph sahaja. Semua calculations pada foolscap atau A4. So
Okay.
ikut susunan, okay? Ikut susunan. So selepas procedure, observation. So observation semua benda ini kamu tulis ikut urutan yang saya tunjuk tadi. Start from graph. Start from table, sorry. Start from table.
Okay.
Madam,
Yes?
I have a question.
Yes?
Untuk graf tu kan, contoh kita, untuk T-squared kita dapat 0.089 dekat data dia, and then kalau nak buat dekat graf tu, can we bundarkan?
Ya, bundarkan.
Okay, thank you.
Okay, so biar kita habiskan pengiraan, so let us finish the calculations. Alright, don't worry, I will post the videos to YouTube tonight, okay? I will make sure everything is up on the YouTube tonight so that you can have time to go through it again, have time to plot it again, try it again. Alright, now let us see, how are we going to do calculations? So after you got a gradient, actually we have to go back to the original equations, okay, which is h equals to 1 over 2 gt. So these equations, we always have to compare with y equals to mx plus c. So by comparison, we know that h is our y, and then t squared represents our x in the graph. And there's no plus minus after half gt squared, which means it's actually a plus 0. Okay, therefore, we always say that theoretically the graph should start from 0 because that is based on the equation. So which means the remaining part, half g, is our gradient. Therefore, by comparison, m is equals to half g. So rearrange the equations now. Why? Because we want to calculate gravity due to accelerations due to gravity. Terbalik pula. Okay, we want to calculate acceleration due to gravity. So rearrange the equations, we get g equals to 2m. All right, so from here, you will be able to get the values of g in terms of m as -2. So this is g experiment, okay, g experiment. So what are we going to do after we obtain this value? Now, since you are not given delta m, you cannot calculate the percentage of uncertainty, but you can calculate the percentage of error. Why? Because we have g theoretical. So g theoretical is equals to 9.81 ms -2, right? Therefore, we can calculate percentage of error. So percentage of error is the percentage of error is the comparisons between experiments, the value and theoretical value. Percentage of uncertainty, we look at what happens to the uncertainty. Okay, we look at the uncertainty, contribute how many percent of error towards our readings. So percentage of error is equals to modulus G experiment, okay, minus G theory, or you want to use G theory minus G experiment also can, divided by G theory, okay, G theoretical. So you can just write GE and GT also can, all right, so times 100%, okay, times 100%. So you will get a value. Now, this value, it plays a very important role. Since now we have the theoretical value, okay? If this value is less than 20%, then we can say this value is very good, okay? It is acceptable. If it's larger than 20%, actually the reading is not acceptable. So the objective is not achieved. But it seldom happens, okay? It seldom happens. Unless you make a huge mistake in the experiment, then you will get an error that is greater than 20%. So if the error is less than 20%, then the readings is accepted. All right, the reading is accepted. So we can accept the range up to plus minus 20%. So you can write that in your first paragraph of discussion. So after you state the value, your results, and then you state the percentage of error, and then you state whether the result, your experimental value is accepted or not, based on percentage of error. Okay, based on the percentage of error. So done, okay? When you reach this step, when you calculate, you obtain the percentage of error that marks the ends of the observation. Then you can proceed to discussion. So discussion, same things. First paragraph, you discuss about the results. Second paragraph, 2 errors. Third paragraph, 2 precautions. And then at the end, conclusions. Conclusions, you say objective is achieved or not achieved, and then state your result as a proof. Okay, your result, which is the G as the proof. Okay, because the objective asks you to determine the accelerations due to gravity. All right, so that is the end. So any questions? No questions. So if no questions, then you just write it down. All right, and if no more questions and you're done, then you may leave the class.